This video will show you how to constrain your model for finite element analysis using Patran 2010. Here in Patran, I have a plate geometric model that I want to constrain properly. Now, I haven't created my finite element mesh yet, but that's okay because I can apply my constraint to the geometry and then it'll be transferred to the finite elements once they're created. So for my model, I have two flat plates here that I want to constrain. So under loads and boundary conditions, I'll select displacement constraint. My action, object, and type are create, displacement, nodal. So I'll give it a name, in this case fixed, 1, and I'll input my data. I can constrain translation. So by entering 0 here, I'll be fixing the x, y, and z translation to be 0. Now I could enter a non-zero value here, and that would apply enforced displacement, but that's really more of a load. I can also constrain all of the rotations to be 0 as well, for all of the points that I select with this application region. So I click Select Application Region, and here I can pick geometric entities to apply this constraint to. Now I want to be careful not to select too large of an application region. I could select this entire plate if I want, but that would make my analysis rather trivial because it would be fully fixed. Nothing could move in any direction. So instead I want to just apply this at one point. So this bottom left of my left plate I'll use as my application region. I'll click Add, OK, and now Apply. And the blue markers indicate that I've constrained all 6 degrees of freedom for that point. So x, y, and z translation, and rotation about the x, y, and z axis. Now that constraint alone is enough to fully constrain this plate because it can't move in any rigid body way with that point constrained that way. Now the right plate is still totally free, and we'll get back to that later. But because it's important to consider rotations in your model, I'm going to modify that displacement and remove the rotational constraint there. So we're going to modify our fixed and then modify its data. And to remove the rotational constraint, I'll just delete these zeros and so that the rotations are again left blank. So I'll click OK and Apply. And now I can see that I'm only constraining the 1, 2, and 3, or x, y, and z direction translation for that point. Now this is not enough to fully constrain the left plate because it can rotate about either axis. So I'll need to create additional boundary conditions, which I can do. I'll create displacement nodal again, and in this case I'll create fixed 2 and input its data. Now I could constrain all 3 translations for another point elsewhere on the plate, and that would help, but I have to be aware that I don't over-constrain this plate and unrealistically restrict its movement. So in this case, I only want to constrain the x and z translations of another point. So in order to do that, what I'll do is I'll leave the value for y translation blank. So I'm entering 0, comma, space, comma, 0. So that I'm constraining the x and the z while leaving the y blank. So I'll click OK, select Application Region, and in this case I want to apply this to this top point here. I'll add, OK, and apply, and now my markers indicate that I've constrained the 1 and 3, or x and z translation. Now the reason I didn't want to constrain the y translation there is that wouldn't allow this plate to expand or contract with load along this y direction. And that might be an unrealistic constraint. So the model would in effect be over-constrained. So it's important to think about your realistic loading situation as you apply your constraints to your model. Now I still need to apply one more constraint to fully fix this plate because currently it could rotate about the y-axis along this line. So I'll go ahead and create one more fixed constraint. And in this case, I'll only constrain translation in the z direction. So for my value, I'll leave both the x and the y blank, and fix the z to be 0. I'll click OK, select my application region, and I'll pick this point at the right edge of that plate, add, OK, and apply. So now my left plate is fully constrained. With this combination of translation constraints, I've removed all possible rigid body motion for this plate. And I've also been aware not to over-constrain the plate by restricting too many degrees of freedom. So finally, another factor that I need to consider is this right plate over here. Now, if I need it to be properly constrained, I could either create its own set of constraints that apply to this plate if I want it to be a separate object, or I need to tie it properly to this plate on the left. And I can tie those two plates together as part of the meshing process. So I'll just quickly create a mesh on these surfaces. And I can see that, okay, now they've been meshed, but they're still two independent plates. And if I were to run this model, I would get an error. Nastran wouldn't complete. I'd have an excessive pivot ratios error that you'll often see when a model is under constrained. And that's because all of the nodes and elements on this right plate are free to move wherever they want. There's no constraint being applied there. So if I want to tie these two plates together, I do that by equivalencing the model. I can first verify that they are two separate plates. I can see that there's a free edge here between them. And then I can equivalence the model to remove that and connect the unconstrained plate to the constrained plate. Again, I won't want to exclude any nodes from this, so I'll leave this field blank, and all of the duplicate nodes will be removed. And that's what I can see here. There were 6 coincident nodes that were shared between, along the edge between these two plates. So now with those nodes being deleted and the elements tied together at common nodes, this model is now fully constrained by the finite element mesh. So again, it's important to make sure that you have properly constrained your model and removed the appropriate rigid body motions from your model. And you can do that by directly creating your displacement constraints. But even so, you need to be aware of where and how, and which degrees of freedom you constrain at different points in your model. And finally, you need to make sure that your model is continuous so that your constraints are applied throughout.